Hi, AT from CNC at Home. When you burn with a laser, it does something called burning a kerf, or just has a kerf. We have the same phenomenon when we cut with any kind of saw, whether it be a bandsaw or a circular saw. And it's the width of the blade when you're dealing with a saw, and that's very easy to measure. You just go up with a ruler or a caliper and you measure the fat part of your blade, and then you know what the kerf is, 1/8 inch, typical for like a circular saw. The other thing you can do is you can cut a piece of wood. Just cut it and measure the width of that cut. With your laser, you have a kerf. You're burning away material, and it's essentially the width of your laser beam. And it's difficult to go in with a caliper and try and measure the laser beam. That's not really an easy thing to do. LightBurn came out with a little tips and hints video. I'll put the description down in my description. I'll put the link down in my description to that video, and it talks about how to measure kerf for your laser. And what they do is, instead of just making one cut, they make 20 cuts. And what that does is it makes larger number to measure. So essentially it makes 20 cuts and then takes those pieces that you've cut and squish them all together. And then now we know, well, what it used to be and what it is, and then divide by 20, and that's the width of our laser beam, or our kerf. We divide that in half again. I'll explain that later. It's something that I've always wanted to do, and they have a template for you to burn. So download that template, load it into LightBurn, set up your parameters, and then burn it. They also have a couple finger joint pieces that you can burn and test it out. So I'm going to do that. I'm going to burn those out without my kerf setting, and then I will burn out another set once we've measured the kerf. I'll add that in and see how much of a tighter fit we get. It should be nice and tight. I find sometimes that adjusting for the kerf with finger joints makes them too tight. And I have had a project where I had to use a hammer to get my pieces to fit instead of going through and doing a ton of sanding. So you always decide whether the kerf is important or not. If you want a nice tight fit, adjust for the kerf. If you don't really care or it's not that important, leave it off. It's up to you. Let's take a look at that template that LightBurn has available and see how we might want to adjust that. If you like this video, give it a thumbs up. We'll go into LightBurn, get that set up, and then burn out a kerf measuring tool. When we first opened our kerf project, I noticed that it was saved in a much later version of LightBurn. I'm using 2.0.04, and this was saved using 2.1.00. That's unreleased. And I know this because I went and said, well, update me. And I'm at the current update. So this was done with a newer version. Shouldn't cause any issues. Go ahead and just click yes, you want to continue. It'll bring it in when you save it. I didn't find anything that was lost. It's also off the bottom of my work area, so I'm just going to put it in the lower left-hand corner and then just do a quick zoom in on it so we can see what's going on. This is our kerf measurement tool, and these two finger joints are here for testing. And I'm going to put them on a separate layer so I have a little more control over those. And I already have my parameters set here. Let's go ahead and set our red layer to cut. So this is my plywood 3mm cut through. Go ahead and assign that. Go ahead and assign that to our black layer, because that's where it's going to do our text. And for now, we will not output these finger joints. We'll do that later. We'll do one with kerf and one without, and then compare the fitment on those. The way that this kerf offset tool works, it looks like there's rectangles in here, but they're really just vertical lines. We just ungroup that. We can come in and we can see These are just individual lines. It's only going to cut them once. I was thinking that these were rectangles just copied across, bumped up to each other, so I wanted to go into my optimization and turn on remove overlapping lines to speed this up, and it didn't change how fast this went. And as I looked into it, it's like, oh, these are just individual lines, so it wasn't going to cut them twice anyway. This is our veneer scale at the bottom, and this is the major scale up here. So each one of these tick marks represents a millimeter. And then down here, each one of these represents 1/10 of a millimeter. With our parameters set, we can go ahead and send this to the laser and burn it out. How this will end up working is each one of these vertical lines is a full kerf. And there are 20 lines across here. So once these are all burned out, this little slider piece, you push over to the right and it bumps all these up next to each other. And then this line slides over however far your kerf is. And then that's how you get the numbers here. When you're cutting, you need to decide how much of that kerf you're going to use. Normally, you're only going to use half of it. So if you think of your laser as a circle, we'll just draw a large circle here for a second so we can kind of see that. If we are cutting an edge, it's going to be right on there. So it's going to cut half of your kerf off the material and half of it in the material. So what you want to do is divide this kerf number in half so that it's writing more like that, so that it's completely off the material and you're cutting this exactly to size. One of the things that I want to look into is the shape of my laser dot. They're not always round. On my very first laser, it was more of a rhombus, where it was a square that was tilted off to the side. And depending on whether you were cutting vertically or horizontally, the size of the kerf was a little different. At this point, we're ready to go ahead and send this to the laser, so let's do that and get it burned out. Okay, let's do a quick test here. We'll do a frame. And let's go ahead and burn those finger joints with no kerf adjustment. My kerf measuring tool all set up. I've got it pulled all the way over to the right, nice and tight, so we can get a good reading. And our D is just past the 1, close to 1.5. So we go down to our vernier to get a better reading. Our half, it's the line down here isn't quite to it. It's the 6. So we basically have 1.6 millimeter kerf, and we divide that by 20 because there are 20 cuts across here. When we divide that by 20, we have 0.08. That's the actual size of our laser kerf. When we put in our adjustment, we only need to move half that distance over, so we put in 0.04. Let's take a look and see how that actually works. I cut out the finger joint test, and I did it without any kerf adjustment. We put these two pieces together and they fit nicely, and as you can see, there's just the slightest bit of movement there, and they're loose. And that's a lot of times how I do my finger joints. They're nice and loose, a little bit of slop, and that allows me to manipulate something as I'm gluing it to make sure it all fits correctly. If you have a good design, well, here's with 0.04 kerf offset. And we slide these together, it's tight. It's tight. It's so tight it holds together. They don't need any glue. So it's a good friction fit. So there's virtually no slop in this whatsoever. Do we use kerf? Don't we use kerf? That's going to depend on the project. It's good to know what my actual kerf value is, 0.04, and I get a nice tight finger joint. The kerf measuring tool turned out really nicely, and I was able to get a nice accurate reading of 0.08 for my kerf, dividing that in half, 0.04. As I showed with the little finger joint experiment, it with no kerf, it's a little loose. It fits together real easily. There's just a little bit of wiggle. Kind of how I've normally done my finger joints. Again, it's personal preference. I like them a little loose. That way I can adjust whatever I'm putting together as I'm gluing it to get it into the right spot. If the design is really good, though, you might want to use the kerf, and then we get this nice tight friction fit here. With the, for me, it's a 0.04 kerf, so half the kerf. When I do the outside cutting. On an inside, I'd want to go negative 0.04. Anyway, if you like this video, give it a thumbs up. Check out the LightBurn template for the kerf measuring tool. Again, the link's down in the description below. And if you like the content of our channel, think about subscribing. That really helps us out. Enjoy doing your CNC at home projects. Maybe adjust your cuts with some kerf. Couldn't hurt. Oops.